Again, more max and min. Let's keep going. Huh? What's this? Video 3. Now our little exploration through some algebra. Don't worry, we'll get to some calculus. Sure, we'll get to some calculus. So now we're going to want to go deal with what we call the extreme value theorem. And it's pretty frickin' straightforward once you see it. Like, all the words might, of course, freak you out a bit, I think, but once we make the graphs, just hang in. Once we start making these graphs, I think it becomes really pretty freaking clear. So let us go down to our slide. Hey, there's our maxes and our mins. We're done talking about that for a little while. You won't ever lose that, though. And here we go. Here's our extreme value theorem. Of course, lots of words. But we're going to read it real quick. If f is continuous, I'm just going to highlight that word, continuous on a closed interval, then f obtains an absolute maximum value, f of c, and an absolute minimum value, f of d, for two numbers in the interval between a and b. So we said a lot of A's, B's, C's, D's, F's. We're going to mention E. But let's just make sure. It's like, as long as we got some shit that's continuous, and we got a closed interval, then we're going to get a max and a min. Absolute max and a min on a closed interval. I'll take you back to this one. We did this one at the... All right. This was on a closed interval. Therefore, there had to be an absolute max and absolute min between. That's what since it's continuous and it's closed, this was only from -1 up to 4, right? We obtained an absolute max. It was right here. And we obtained an absolute min, and it was right down here. This is always going to happen for a closed interval that's continuous. So let's go down here to our extreme value theorem, and let's just make some graphs. And I think this isn't so bad, so I'm just going to make a point. And I'll make another point. And I'm going to pause for a second, just say, all right, now you graph that thing to where it's continuous in between and make sure there's no absolute max or min. It doesn't matter how you make it. Maybe you just make a straight line. All right, max, min, found it. So there would be our A and our B at the intervals. It just happened to be that our those two numbers, the C and the D, in that closed interval just happen to be the freaking endpoints. Oh, okay. Remember, continuous. So now let's make some other A and some other B. Let's make some points. Let's make them. Oh, I know what we can do. Let's make them at the same freaking height. And maybe now it goes, and we go through. Well, I don't know what all that meant, but all right, cool. So then we have some sort of max hanging out right here. We got some sort of, I think the min would be right here. So we call it. So like maybe we make the max was some C value, and then there was some min, and that thing was some D value. Right, so we're just saying maxes and mins. That if you have a closed interval and it is continuous, there will always be a max and a min within that closed interval. Let's keep looking. Is there anything we can do? Anything else? I think I've made too many of these things. Maybe we have a graph like that going from A to B. Maybe it pops up and it only does this. Oh, there we go. So we only have right now, the only thing we have is a little bit of a max. Just a max, so therefore, so we just have that C there. And then to find our min, well, that happened to be one more time. That just happened to be the endpoint. So when we say that there must be some other D as well, well, A and D are just the same dang thing. Now let's show a couple contradictions to this, how we wouldn't necessarily obtain one. So we're not going to follow all the rules here. So I'm going to write it in red, so we're not following the rules. Let's say we got some point A, then we got some point B. Now you tell me if we got a max or a min. So I'll make the point down here. We'll make B right here. So here we go. Cool. What rule did I break? Yep. It must be continuous. And it must be on a closed interval for this to work. Those two things. Must be continuous. Must be on a closed interval. Those two things. Those are the covering your ass so you can actually make the frickin' statement. They must be true. So right here, it does not work. This is not one of those cases. Not a case that's going to work. We could also have other things, just basically with asymptotes. Even here, let me give you another example of something kind of strange. Say we have some A, and we'll make a point up here. We got some B, and we got a point that's right here. All right, it's closed. Now I'm going to play connect the dots, but right here I'm going to make a hole. Nope. That doesn't achieve it because, well, we have a hole right there where the max would have been. Right? It never achieved that value. So we've now seen a couple of examples of where the extreme value theorem works. Up top. And where it does not work. Down below. So we got a couple of examples of where it works and where it doesn't. So extreme value theorem, we're going to be using this concept in what we call the closed interval method. It's not a theorem or anything. It's a game that we're going to play, or maybe you call it a problem. But we're going to use this concept where we're going to find absolute mins and maxes in a closed interval, hence the closed interval method. We're going to use this by finding midpoint, or finding local mins and maxes in between, and maybe some endpoints. Notice how some of our mins were endpoints, some of them were just local mins and local maxes. All right, they're also absolutes. We'll see you in the next one.